Oh, hello. So today I'll be demonstrating my task 5.2c, which was changing the light intensity of the Raspberry Pi GUI using sliders. Uh, so the task sheet was, according to the task sheet, the task was building a basic breadboard interface that allows you to turn on and off an LED. At this time, we need to use sliders and use PWM modulation to change the intensity of the light bulbs. And as I'm an SIT 730 student, I had to add a timer function to start the change of light intensity, and for two or more lights it should happen on its own. So I'll first uh, I'll first show the video for the same so that the hardware and software will be easier to explain later. So as you can see, the blue and the green lights are turning on and off by themselves using the timer. I'm not controlling them in any way, but we can use the slider for the red LED, uh, using which the using PWM modulation, we can increase the temperature of red. Like right now, the PWM is almost close to 100, so it turned on completely, and it's close to 0, so it turned off. While this is ongoing, the blue and green lights are working on their own using timer functions. So this was what the task wanted us to achieve. Uh, yeah, now I'll go through the code. So this is the PWM-led GUI controller, which enables dynamic brightness control using PWM and Raspberry Pi. So there is manual control for the red LED and automatic fading behavior for the green and blue LEDs. Uh, so we're using a Qt-based library to give a clean user interface. Components required will be Raspberry Pi. The breadboard is actually not necessary, but we're using it for the LEDs. Uh, so three LEDs, red, green, blue, then the registers to connect to the breadboard. Uh, the jumper wires. Yeah, I had to use the breadboard for this project in order to make the LEDs work. So the GPIO pin mappings are the red, green, blue code connect to the 17 GPIO 27 respectively, and the physical pins are as follows. For the LEDs, we connect a long leg to the resistor, and the other end is goes to the GPIO pin, which was stated above. That is the cathode. Um, After we make those connections, we turn to the software. We have to SSH first into our Raspberry Pi machine, install all these default libraries to get the Qt and PIO modulation working. We run the qmake libraries to create the executable. Uh, yeah, and then we configure the display and some permissions and run our task. We get a slider which is ranging from 0 to 255, and we can adjust our brightness accordingly. While there is a queue timer function that is written for the green and blue LEDs, uh, which essentially will help us generate the fading out and fading in behavior, which is complementary between these two. Yeah, it sometimes might look like we're waiting for one LED to completely turn on and off before the other one starts. This is due to the perception being non-linear from 128 to 255. As our eyes cannot perceive that the difference between on and slightly less on up to 50%, but then it becomes more visually clear. Yeah, and that was the task. The code for the same in PWM underscore GUICPP. You can check all of this on the GitHub. We define the green, blue, and red LEDs. We set up the GPIO. We set up the LED slider. Uh, this is the core function where we timer function for green and blue LEDs, where if one LED goes into a state increasing mechanism where we keep the brightness equal to 255 and one is equal to 0, and we use a step. So this will keep on increasing, this will keep on decreasing, and once they go past a certain value, then we change the state, increasing to false for and true for the other one. So we get the complementary effect using this logic. Yeah, and here we connect everything to our GPIO PWMs. The red one is connected to the manual library, so I could show it. Yeah, so The red slider is connected to the red LED, so this one works manually, not with the timer function. Yeah, and using that we get the respective output for the same. The first task was just simply sliders, which is the code used for the red slider. So it's pretty much the same, just with less code. Yeah, and that's it. Thank you.